mixtures can be separated by physical processes. A sequence of physical processes can be used to separate common salts, sodium chloride, from a mixture containing sand and common salt only. So take care, here we have a mixture of sand and common salt. Give the order and the correct scientific term for the physical processes used to separate the common salt from the mixture. Take care, guys, please hear the word order and check with me now the 4. Here we have 4 marks, and here we have 3 points. 1, 2, 3. So of course 3 processes you should mention, and take care the 4th mark will be for the correct order or the correct arrangement. Okay, so if we have, this is sand particles with salt particle. So remember that here, guys, we have sand. They are insoluble, and salt is soluble substance. So if you have soluble and insoluble together, so the first process you should use, it should be dissolving. Dissolving. So in this case, salt only will dissolve in water, and then you will have a precipitate of sand. So sand will be a precipitate now. How can we get rid of this precipitate? Remember, we said a little earlier that we can do filtration. So you can do filtration to obtain sand. And finally, you will have a solution of water and salt. So how can we get the salt only? So remember, we can't use distillation because in this case we will obtain water, but here we need to obtain salt itself. So in case of obtaining salt, actually we need to make only evaporation process. Only evaporation. So, okay, next part, here we have the boiling points of 4 different alcohols, A, B, C, and D are shown. So you see here different boiling points of different alcohols, A, B, C, and D. A student suggested that the apparatus shown could be used to separate the mixtures of alcohols. So this is the apparatus. Here we have, this is hot water in the flask. This is electric heater, fractionating column, and here this is X. Mixture of alcohols, A, B, C, and D. And here this is the liquid. Okay, so the first question is apparatus X needs to have cold water flowing through it. Draw an arrow on the diagram to show where the cold water enters apparatus X, and also name apparatus X. So let's come back to apparatus X. So actually apparatus X, it's clear, it's condenser. So the apparatus X is condenser, guys. And now we should also draw an arrow to, according to this point, draw an arrow to show where the cold water enters. So here actually we have 2 openings, guys, the one at the bottom and here the one at the top. So which one is going to be more appropriate? Just remember here, this is the best for the vapors within the condenser. So it's clear, guys, this is the final position, and afterwards the liquid will be taken here. So it's more appropriate here for the cold water to be supplied through the bottom one rather than the one above. So we can remove this one above. So the correct answer will be the one at the bottom, because this is the final position for the vapor to touch the condenser before being obtained. Okay, so let's continue. Okay, next one, part of the fractionating column is missing. This means that the experiment will not work. Draw on the diagram the part of the fractionating column which is missing. So let's check. Yeah, here this is fractionating column. So actually, guys, you see this part is open. So of course it will allow gases, it will allow also vapors to escape. So we should close this opening by using this stopper. So you should draw this stopper to close the fractionating column in order to prevent the gases and vapors from escaping and to direct them to the condenser to get them finally. So this is the missed part, which is this is stopper. Okay, the next one, explain why the experiment will not work with this part of the fractionating column missing. Okay, so as we have said, so this is because gases and, vapors escape. Okay, so here we have 2 marks, 1 mark for this point and 1 mark for drawing stopper above. Okay, next one, triple I suggests why a Bunsen burner is not used to heat the flask. So let's check. Okay, here we have electric heater rather than Bunsen burner. So if you check, you'll find, guys, within the flask we have a mixture of alcohols. And you know, alcohols are flammable liquids, so they can catch fire. So it's gonna be very dangerous to use Bunsen burner. So instead, it's more safe to use electric heater, of course. So we can say because mixture of alcohol is flammable. Okay. Okay, the next one, a hot water bath can't be used to separate alcohol C and D. Explain why. Okay, let's check. Here we have, this is the hot water bath. This one. And here this is alcohol C and D. Yeah. Here it's a clear C and D, the boiling point, this is 122 and here this is 160. And you know, guys, for water bath, so it boils at only 100 degrees Celsius, not more. So of course, hot water now, or this water bath, can't be used for separating these alcohols. This is because we can say water bath boils at 100 degrees Celsius, so it cannot exceed. And second point, so C and D alcohols have boiling points more than 100 degrees Celsius.